discuss about finding of Armstrong number. So which number we call it as an Armstrong? First we'll see the logic and then we'll implement the same in Python programming. So usually the Armstrong number means sum of cubes of individual digits sum of cubes of individual digits is equal to a given number, then we call it as a Armstrong number. But this definition is a partially correct. This definition is a partial correct. It's not a perfect definition. Partial correct. So what is the correct definition? So this Armstrong number, finding of this Armstrong number depends upon the number of digits of a given number. Number of digits of a given number. So first we need to find the number of digits of a given number and then we have to find the logic. See, this definition is correct only for a 3-digit number. 3-digit number. Right? So in order to find whether the 3-digit number is an Armstrong, this definition is correct. That means sum of cubes of individual digits. And if it is a 2-digit number, see, if it is a 2-digit number, then sum of squares of individual digits must be equal to that given number. And if it is a 4-digit number, so we need to find out the sum of individual digits power 4. Individual digits power 4. And if it is 5-digit number, the individual digits power 5. So that means first we need to find the number of digits of a given number and then we have to apply the logic. So if it is 2-digit, we have to apply the square because the individual digit power 2, that means a square. If it is 3-digit, individual digits power cube, okay, power 3, that means a cube. If it is 4, power 4. So let us take an example. Here. So let us take some 3. So 3 is a 1-digit. So what we have to do? Power 1. We have to use a power 1. 3 power 1 is equal to 3. So which is equal. So 3 is a Armstrong number. 3 is a Armstrong. Right? Next, 153. Let us take this one. So it is a 3-digit number. So we have to apply 1 cube plus 5 cube plus 3 cube, which is equal to 1 plus 125 5 cube plus 27, which is nothing but 153. So it is also an Armstrong number. And for example, if you take some 12, so it is a 2-digit number. So 1 square plus 2 square is equal to 1 plus 4 is equal to 5. So which is not equal to 12. So this is not an Armstrong. This is an Armstrong. But this is not an Armstrong. Similarly, if you go with the 4-digit, 1634, it's a 4-digit, right? So if it is a 4-digit, so 1 power 4 plus 6 power 4 plus 3 power 4 plus 4 power 4. It will be 1 plus 6 power 4. So it is 1296 plus 3 power 4, 81 plus 4 power 4, 256. So if you sum all these things, we will get 1634, which is a same number, given number. So this is also an Armstrong number. So first we need to find the number of digits, and then we'll go with the sum of powers. For this, we'll see. So in order to find the individual digits, simply you can use a mod operator, okay, so that you will get an individual digit, and reduce the value, right? So reduce the number. This is one way we can apply the logic to find the number of digits. And so simply you can increment the count here, increment the count. And one more way is simply apply the string function. Okay, apply the string function to the number given, so that it will convert it into a string, so that we can find the length of this string. In Python we can do like this. So otherwise, if you take n, so simply we have to iterate until n greater than 0, simply find the remainder, so that we can get the individual digits, right? So n mod 10, a single digit will be getting. So let us take a count plus plus, so increment the count value and then reduce the n value, so that finally we can see the count value, that is a number of digits. So this is the logic. In other languages we can find the number of digits by using this logic in other languages. And simply in Python we can apply the n to the typecasting function string, so that it will be converted into a string, so that we can apply the length, so that we will get the length of the number, that means the number of digits available in that number. And then we can simply find out the sum of all these things. So because this will be the power, right? This will be the power. Simply you can use a double star, which is an exponential operator. So and directly we can use a power function. Or here you can import the math module, and we can simply use a power function. So by using this count value as a power in other languages, right? Now let us implement in Python. First let me take the n value. N is equal to, so int of input enter number, right? Enter number, and then I will convert it into string function and find out the length str of n, so that we'll get the length. See, print l. So if I give 1 2 3 4, we'll get a 4, right? Simply 1 2 3, we'll get a 3. So this is a simple function to find out the length. So one more way I'll tell you. So while n greater than 0, simply find out the remainder r is equal to n mod 10, so that we'll get the individual digits, and then use a count value. So count is equal to count plus 1, and simply reduce the n value n mod 10, and finally we can print the count value, so that it will give the number of digits of a given number. So initially give the count value is equal to 0. See, 1 2 3 4, again we got a 4, and if you give 1 2 3, we'll get a 3 as a result, and if you give 1 2 3 4 5, we'll get a 5 as a result. So this is one more way to find the count. Now what we have to do? So we have to find the sum of all the digits. So before that, I will go with some x is equal to n. So because we are reducing that number here, so in the x we are having some n, and also I will go y is equal to n. So I am passing n value to both the variables x and y. So here let us take y n greater than 0. Simply find out the individual digits. So here we'll go with the x. Okay, x greater than 0, r is equal to x mod 10, and sorry, here is equal to r is equal to x mod 10, and now we have to find the sum. Sum is equal to sum plus power function, right? Here r is having the individual digits r. So give the exponential function to the count. If count is 2, r square. If count is 3, r cube. If count is 4, r power 4. So simply I'll give the parenthesis, so that first it will be evaluated and then the addition will be done. And reduce the value. X is equal to x mod 10. Sorry, floor division of 10. So finally we'll get the sum. So finally we have to compare the sum with the original value. So here we have taken n value and here we have updated the n value and here we have updated the x value. So x and n will be changed. So we have to compare with y. So if sum is equal to y, simply you can say print y. So let us okay. So y is an Armstrong number, and if the sum doesn't matches, so that means else part, so simply we can print y is not an Armstrong. So this is how we can find the Armstrong number for n digit number. See, if I go with the 153, some sort of error is given, so let us take sum is equal to sum plus, so we have, yes, so we should take sum is equal to 0 initially, because we are performing the sum operation, we are updating the sum but we have not given any value, so I have given 0 initially. So 153, so we can get 153 is an Armstrong number, and simply just now we have seen the example, that is 1634, 4 digit number is also an Armstrong number. So if you take 123, it's not an Armstrong number because 1 cube plus 2 cube plus 3 cube, right, and doesn't equal to 123. And if you give 3, it's a single digit number, so it will be an Armstrong number. And if you take 1 2 3 4 5 digit number, it's not an Armstrong number, right? So this is a simple process to find the Armstrong number, n digit Armstrong number, right? So this is one way we can convert the number type into a string type and find the length, so that we'll get the number of digits of a given number. Otherwise, simply iterate the number and find out the remainder, that means individual digits, and find out the count and reduce the number, so that the count is nothing but the number of digits of a given number, right? So once again we are using the sum function, sum is equal to sum plus remainder power count. So previously we have calculated the count, which is nothing but a number of digits, so that should be the power of the remainder, that means an individual digit, right? So we can compare the sum with the given number. So if both are equal, we can say it is a Armstrong. If not, we can say it is not an Armstrong number, right? So don't get confused here. In the process of finding the individual digits, we are updating the n value, and here in the process of finding the sum, we are updating the x value. So while after taking the n value, we are assigning the n value to x and y, so that in one process we are updating the n, in another process we are updating the x. So we are comparing the final sum with y value, right? So hope you understood this one. So if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really understood my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll see one more number program, that is an automorphic number. So first let us see what is an automorphic number, and then we'll go to the logic, and then we'll implement in Python. Automorphic number. So when we call it as an automorphic number, so if the square of number ends with given number, then we can call it as automorphic number. So let us take an example so that you will be understanding. So example 1, so let us take n is equal to some 5. So what is the square here? N power n into n, which is a square, right? It's a 25. So here ends with 5, which is equal to n, right? So then we can simply say 5 is automorphic number. Similarly, let us take one more example, example 2. So now you can simply take n is equal to some 25. So n into n, that is a square, is equal to 625. So it also ends with 25, which is equal to n. That implies we can say 25 is automorphic number, right? So this is how we have to find whether the given number is automorphic or not. Now we'll see the logic and then we'll implement that. So we know that if you want to get the individual digits, we have to use a mod operator, right? Let us take an example here. Some n is equal to 25 and some square is equal to n into n, which is 625. Now what we have to do, we have to find it is ends with a n or not. So if you use a mod operator, some r is equal to square mod 10, we'll get individual digits 5, right? So if it doesn't, this is the first iteration, right? This is the first iteration. If it doesn't ends with, so we need to compare this r value with n. If doesn't matches in the second iteration, so this is a first iteration, so in the first iteration we'll get only single digit, so it may be a double digit, so then we have to update this one, right? Then in the second iteration, what we have to do, we have to mod the square with 100, so that we'll get the two digit number. So you can observe in this example 625 mod 100, which is nothing but 25. So we'll get a last two digits. So let us consider one variable. As a 10. In the first iteration, just go with the thing square mod t. In the second iteration, simply update the t value. So that means if the r is not equal to n, simply go with the next iteration by updating the t with 10, multiplying t with 10. So if you apply like this, we will get the digits, okay, individual digits. So in the first iteration we'll get a single digit, in the second iteration we'll get two digits, and in the third iteration we'll get three digits, right? So let us implement the same thing. Hope you understood this one. So we have to find the digits and we have to compare with n. If it is success, we can simply display the number is a automorphic, and if not, we have to update the denominator in the mod operation, and then again we have to repeat the same process until the n value greater than 0. I mean not greater than 0. Okay, n value not greater than 0. Now I will show you the implementation so that you will be understanding more. So first let us take the n value. N is equal to input enter number, and after that what we have to do, we have to place the n value in one more number in order to check that one. So I will take some x is equal to n, and then find out the square. So square is equal to sq is equal to n into n, or simply you can go use a exponential operator n double star 2. And also for the denominator, let us take t is equal to 10, and if you want to get a two digit number, we have to update the t value by multiplying with 10. So repeat the process until n greater than 0, and simply find out the remainder first with 10 and check the remainder with a value. R is equal to, so we have to check the square mod t, and if r is equal to x, x, so simply change the flag as 1 and break, because the number ends with the particular number, right? If not update the, reduce the number of digits. N is equal to n mod 10, and update the t value for the next iteration. T is equal to t into 10, so that in the next iteration we'll get a two digit number, right? In the first iteration we are getting only one digit number, in the second iteration we are getting two digit number. Now repeat the process until n greater than 0, and finally you can check if the flag is equal to 1, so we can say that n, sorry, p is, sorry, not a p, x. So we have stored the n value in x, right? So x is automorphic number. If the false condition, in the false condition, simply you can also print x is not automorphic number. So here we are using the flag, so here we'll declare the flag as 0, right? Now you can execute this one. Sorry, yes, so this is a assignment operator. We have to use a comparative operator. So I will go with the 25. So 25 is an automorphic number because 25 ends with the 25. Okay, so here you can also print x as well as, simply we'll go with the number is x and square of number is what is this one, sq, right? So execute. If you go with the 25, so number is 25 and square of number is 625. So the square of number ends with 25, so we got 25 is a automorphic. And if you go with the 4, so 4 is not automorphic because use the same thing here. So then you will be knowing why the number is not automorphic. So number is 4 and the square of a number is 16. So this number doesn't ends with the given number. So that's why 4 is not a automorphic number. Once again, 5. So number is a 5 and a square of a number is a 25. So 25 ends with a 5. So that's why 5 is a automorphic number. So what we have done, first we have taken the input from the keyboard, we have saved it in n, and we are assigning one more variable, and to that variable we are assigning the n value, we are finding the square, and we are assigning t value as 10 because to find the single digit, double digit, triple digit and so on for every iteration. And we have to iterate until the n greater than 0, that means until the n reaches to 0. So r is equal to, r means a reminder, so we know that we'll get the reminder by using the mod operator. Reminder is equal to square root s cube mod t, where initially t is 10, so we'll get a single digit. So we are comparing that particular single digit with x. Okay, x in the x we are holding the n value. So if it is true, simply we are initializing the flag to 1 and we are just break the statement because we required that the number is end of the square of a number. So if not, so reduce the number of digits and update the t value with 10, multiplying with 10, because in the next iteration if you apply the mod operator with 100, we will get a 2-digit number. So we can compare the 2-digit number with x. If not, 3-digit number with x. If not, 4-digit with the number with x. So we have to repeat the same process until the n greater than 0. So finally, based upon the flag value, we are deciding that whether the number is automorphic or not. Right? So hope you understood this one. So if you are having any doubts regarding this automorphic number, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll see one more program, that is to find whether the given number is a buzz number or not. So first let us see what is this buzz number. So a number is called a buzz number if that number ends with a digit 7 or it is divisible by 7, right? So buzz number. So here we have to take two constraints. One is the number should end with 7, or number should be divisible by 7. So if any one of the constraint is true, automatically we can say the number as a buzz number, right? So let us execute this one first. Let me take the number. I will read the number. So n is equal to int of input, and here we can give enter number, right? Now we need to check the two constraints. One is the number should end with 7. So if you want to get the individual digits, we need to use the mod operator, right? So I will write the condition if n mod 10 is equal to 7, right? So for example, consider, so I'm writing some example. So consider 107. So if you take 107, so 107 modulo 10, which will give the result as 7, right? So the last digit will be getting, right? If you mod the number with a 10, we'll get the last digit. So if this digit is equal to 7, or one more thing, the number should be divisible by 7. So simply we can say n mod 7 is equal to 0. That means, see, if it is a 49, the number is 49. So 49 mod 7. So again it gives 0, right? The remainder, it will give remainder. So if it is 0, that implies the number is divisible by 7. So this is the option for finding the last digit, and this is the option for whether it is a divisor or not. So you can simply go with this one. If n mod 10 is equal to 7, or n mod 7 is equal to 0. If any one of this thing is true, simply we can say a number is a buzz number, and in the false condition, so in the false case, we can simply print n is not a buzz number, right? See, for example, I will go with 107, so it's a buzz number. And if I go with the 104, so it will check whether the last digit is 7. So this number doesn't have the last digit as 7, and it will find whether this number is divisible by 7 or not. So it's not divisible by 7, so automatically we can say 104 is not a buzz number. One more example, if you take some 63, so here also the last digit is not a 7, so again it will check for the divisor. So 63 mod 7 is equal to 0. Yes, this is true. So that's why this number will be a buzz number, right? So it should satisfy any one condition. That means the last digit of the number must be 7, or that number should be divisible by 7. So any one of the constraint is true, then we can say the number is a buzz number. So hope you understood this one. If you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll check one more Python program to find whether the given number is DISARIUM number or not. First, let us see what is this DISARIUM number and how can we find it, and then we'll go with the programming logic. So DISARIUM number. So a number is said to be the DISARIUM number when the sum of its digits, the individual digits, raised to the power of their respective positions is equal to given number, then we can call it as a DISARIUM number, right? Sum of digits raised to the power of their respective positions is equal to the given number. So example, let me tell you an example so that you will be understanding more, right? So let us take an example as 989. So the position of 9 is 2 and position of 8 is 1, right? So this is the positions. This is the first position, this is the second position, right? Now we need to find the sum of digits raised to its positions, right? Power of its positions. Power of its positions. Now 8, see, for better understanding I am writing this one, power of 8 with 1 plus power of 9 with a 2. That means, see, 8 power 1, 8 plus 9 square, that's a 81. So which is equal to 89. So our given number is 89 and we are finding the position of 8 and we are finding the position of 9, and then we are just adding those powers. So 8 power 1, because the position of 8 is 1, so 8 power 1. The position of 9 is 2, so we need to find 9 power 2. So we need to sum these two things so that we have to get the given number. So if we get the same number, then we call it as a DISARIUM number, right? Now we'll go with the programming logic. So first let us take the input number. So for taking the input number, consider n is equal to int of input enter number. So consider one temporary number. I'll go with the temporary number because we need to identify the positions first and then we have to find out the powers. We need to modify the n value. So, and again finally we have to compare with the same number. So that's why I am just giving one temporary variable and I am assigning the same number to that particular temporary variable. Now first finding positions. So in order to find the position, simply we can go with the length of the digits, okay, length of the number. So for that, just you can observe. So take the while loop and I will go with a temporary greater than 0. So simply you can use temporary is equal to temp mod 10, so that we'll get an individual digit. So we can simply count the iteration, right? So how many iterations it will be counting, so that will be the number of digits. Okay, we'll get the number of digits. For example, before that we have to initialize a count is equal to 0, and see, if I print the count, you can observe execute some 89, so the count is 2, right? And if it is 104, the count is 3. So this is the logic we are writing to find the positions. That means the length. If you got the length, you can observe here 3, the count is 3. We can simply say 4 is the third position, 0 is the second position, and 1 is the first position. So we can decrement the individual number. We can find the individual digit and we can power with this particular count and we can decrease the count value. So after completion of this loop, we'll get the length. Now again I will go with the one more thing. So I will write some one more value, x is equal to n. I will now we'll find the individual digits, right? So while x greater than 0, you can simply use the reminder. Okay, reminder is equal to some x mod 10, so that we'll get the individual digit. Okay, we can get the individual digit. So this is for individual digit. So individual digit, right? So next we have to find the sum. Sum is equal to sum plus, we need to find the power, right? So power means the digit power. So reminder, power operator, exponential operator, and the position. What's the position of the one's position? That is the third position. So if you get x mod 10, for example, so if you take 89, the count here, the count value is 2. So if you apply the mod operator with a 10, we'll get the value as 9. So 9 is at second position, right? So 9 is at second position. Now you can simply go with the count, and simply after that you have to reduce the value. So x is equal to x floor division 10. So it will be reduced to 1 digit, right? If it is 3 digits, Now it will be 2 digits. And now we need to reduce the count. Count is equal to count minus 1. So before going to that, we are applying the sum. So simply give the sum value as 0. Initial sum value as 0. So finally we'll get the sum, and if you check this sum is equal to n, simply we can print it as n is a DISARIUM number, right? And if not, that means a false case. If it is doesn't matches, simply we can say n is not a DISARIUM number. So now you can check. So if you give 89, so 89 is a DISARIUM number because so here we got the count as 2. Okay, so here simply you can print after this one. So print, you can write it here. So count is equal to, so 89. So count is equal to 2. Okay, count is equal to 2, and then now here we are giving the individual digit, and here the remainder into count, and here we are reducing the count value. So will get the if you apply this mod operator, we'll get the ones position, that is the final count, right? So we have to reduce the count one by one. If it is a 3-digit number, the count will be 3, and after that in this position we are reducing the number to the 2-digit, right? So 2-digit, now the position will be count minus 1, that is 2, and next one 1-digit, and the position is 1. So that's why we are using this count. Okay, we are decrementing the count, and you can observe here. So 124, which is not a DISARIUM number, which is not a DISARIUM number. So like this we can find the count. So one more example, we can go with a 135. So 135 is a DISARIUM number because of 5 cube 125, 3 square 9 plus 125. Okay, so here you can observe the position of 1 is 1, and position of 3 is 2, and position of 5 is 3. And here you can see power of 1 comma 1, and here the power of 3 comma 2, because the position of 3 is 2, and here the power of 5 comma 3. So here you can see the power of 1 power 1 1, 3 square 3 square means it's 9, and now 5 cube, it is 125. So you can add 125 plus 9, it's 134 plus 1 135. So the same number, we got the same number. So that's why 135 is also a DISARIUM number, right? So this is the logic to find the DISARIUM number, whether the number is a DISARIUM or not, right? So once again, DISARIUM number means, so the sum of digits raised to the powers of their respective positions is equal to the given number, then we call it as a DISARIUM number, right? So you can use one more way, without using this while loop. You can convert the integer into a string, and you can find the length. Okay, you can find the length, and the rest of the things are equal, right? So hope you understood this one, and if you are having this any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session we'll discuss about one more number program, that is a fascinating number. So first let us see what is a fascinating number, and then we'll see the logic in Python. So here we need to consider the 3-digit number, and if it is the number is if the number is a 3-digit, then only we can check for the fascinating. So other than the 3-digit number, we can't check for the fascinating number. That's the first point. So let me write here. So the first point is fascinating number check can be done for 3-digit number only. So if not 3-digit number, we can't check for the fascinating number. Then if it is a 3-digit number, we need to find the product of that number with 2 and 3. That means multiply the number with 2 and 3, and we need to concatenate that number with both the multiplications of 2 and 3 such that the result should contain the numbers from 1 to 9 exactly once. Then we call it as a fascinating number. So the second point is multiply number with 2 and 3. And the third point, concatenate number with results after multiplying with 2 and 3. The fourth one is we need to check whether the result after concatenation having 1 to 9 in any order exactly once. So this we can say, then we can say it as a fascinating number, right? The first point, the fascinating number check can be done only for the 3-digit number, and first we need to multiply the number with 2 and 3 and concatenate that number with the results after multiplying with 2 and 3, and result of after concatenation should have 1 to 9 in any order exactly once. Let us take an example. So 273 is a number, right? Is a number. Now we need to check 273 into 2 and 273 into 3. So what would be the result here, right? So let us find that product. 273 into 2 is 546, and coming to 273 into 3, it is 819, right? Now we have to concatenate results. See here the result 273, that number plus 546 plus 819, concatenation, right? So then we'll get 273, 546, 819. So here you can see in this concatenation we can see all the digits from 1 to 9 exactly once. You can observe here 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here we need to check after concatenation the length should be 9, and count of digits should not be greater than 1, and count of digits should not be equal to 0. So then we can say it as a fascinating number, right? So fascinating number can be checked only for the 3 digits. We need to multiply with the 2 and 3 and concatenate the results so that we have to get all the digits from 1 to 9 exactly once. We'll see the logic once now by executing the program. So we'll execute the program in Python. So first let me take the number by using the input function. So n is equal to int of input enter number. So I'm taking some number. Now we need to check the length of the thing, right? So I will convert this into a string. So s1 is equal to str of n, and check this one. So if the length of, or directly we can check, I will check directly. If the length of str of n not equal to 3, not equal to 3, print fascinating number check can't be done, right? Else what we have to do, we have to get the results, right? Different results. So n1 is equal to n, n2 is equal to n into 2, n3 is equal to n into 3. So what we have to do, we have to check, get the result, right? So result is equal to, we have to concatenate all these things. So str of n1 plus str of n2 plus str of n3, right? So you can simply add this one. So print result. So you can observe, let us take 273, just a thing, because boolean has no length function. Okay, let us take some L is equal to length of str of n. Okay, sorry, yeah, yes, we are not given, you can observe here. Yes, 273. So we got the number, right? You can see n1, n2, n3, we have concatenated all things. So we got the result 2, 7, 3, 5, 4, 6, 8, 1, 9. So all are equal. Now what we have to do, the next step, we have to compare the length, right? We have to compare the length. So simply use the for loop for number in result. So result is a string, right? Type of result is a string. So I am checking each and everything. So we have to check if the length of, sorry, if the length of result is not equal to 9, it should not be a fascinating, or result dot count of number everything is greater than 1, or result dot count of number is equal to 0. Okay, so what we can simply say, initialize the flag is equal to 1, and break. So if there are any deviation from this one, so if the length is not equal to 9, it's not a fascinating. If the count of each number is greater than 1, it's not a fascinating. And if the count of that particular number is equal to 0, that means the number is not there, not present in that particular string. So then also the fascinating, it's not a fascinating number, right? So if any one of this condition is true, automatically the flag will be set to 1 and we have to break. And after that, simply here check the flag. So if the flag is equal to 1, print not fascinating number. So it's not a fascinating number because it doesn't follow the rules, right? So n is not a fascinating number, and simply else we can simply say that n is fascinating number. So initialize the flag here. So I'll go with the flag here. So I'll initialize the flag is equal to 0 initially. So you can observe here 273. So we got 273 is a fascinating number because here you can observe there is no zeros, I mean there is no repetition of these numbers, and the length is 9. And you can also go with the one more number 123. So 123 is not a fascinating number because here 2 is appeared 2 times, 3 is appeared 2 times, 6 is appeared 2 times. And similarly 5 is missing, 7 is missing, and 8 is missing. So we have to get all the digits at least once, exactly once, not at least, exactly once, right? So see 189, it's also not a fascinating number. So like this we can check the fascinating number. So first we are checking for the length. If length is not equal to the 3, we can simply say that. See, we go with the 12. So fascinating number check can't be done because the number of digits is only 2. So it is only applicable for 3 digit number. So else simply we can go with this one. So n1 is equal to n, n2 I am giving the multiplication with the 2, and n3 is the result of multiplying with 3, and the result I am taking the result by concatenating all these things. So before concatenation I am just applying the string function so that the number will be converted into a string, and I am initializing the flag to 0, and I am now checking each and every element of that particular result, taking each and every element of that particular result and finding these conditions. So if the result is not equal to 9, simply we can say it is not a fascinating, and we are finding the count of the number. So if the count of number is greater than 1, because the count should be exactly once. So if the count of number is greater than 1, so we have to we can say that it is not a fascinating number, and if the count is 0, that means if there is any missing number, then also we can say it is not a fascinating. So we are initializing the flag to 1, and we are just break the loop, and after the loop we are checking with the flag. Based on the value on the flag, we are declaring the result. If the flag is equal to 1, that implies any one of these condition is true, right? The result the length may be not equal to 9, and the result of count may be greater than 1, or is it 0. So like this we can simply find the fascinating number, whether the given number is a fascinating number or not, right? So hope you understood this one, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session we'll see how to find the happy number. So here this is similar to our previous program, that is a magic number. So if you find recursively the sum of individual digits until the sum becomes a single digit and 1, we call it as a magic number. The same process will apply for this happy number also. So let me write the definition first, and then we'll see the logic. So recursively finding sum of squares of individual digits until the sum becomes single digit, and if the final single digit sum is equal to 1, then we call it as happy number. So recursively we are supposed to find the squares of individual digits. Okay, so if the sum of individual digits and finally we get the sum as 1, we call it as a magic number. If you find the sum of squares of individual digits and finally if you get 1, then we call it as a happy number. See example, let us take an example. So consider n is equal to 13. So we need to find whether 13 is a happy number or not. So for that we have to do the sum is equal to 1 square so I am writing some 1 into 1 plus 3 into 3. So sum of squares of individual digits. So which is equal to 1 plus 9, which is equal to 10. Now again sum is equal to, so now it is 10, right? So this is for 13, and now the sum becomes 10 now, right? So which is not a single digit. So again we need to find the sum of squares. So 1 into 1 plus 0 into 0, so which is equal to 1, and it is a single digit. And equals to 1, right? So n is happy number. So we should get 1 for recursively finding the sum of squares of individual digits. So one more example, let us take one more example. So n is equal to some 19. I take the n is equal to 19, second example. Now so 19, So we need to find the sum. Sum is equal to, so 1 into 1 plus 9 into 9, right? So what we get, 1 plus 81, so which is equal to 82. So this is a 2-digit number, not an individual digit. Again we have to find the sum, 82, and sum is equal to 8 into 8 plus 2 into 2. So which is nothing but 64 plus 4. So which is 68. Again, it is not an individual digit. We have to repeat one more time. So 68, if you use a sum, is equal to 6 into 6 plus 8 into 8. So which is nothing but 36 plus 64. So which is equal to 100. And again, this is not a single digit. Again, we need to repeat the same process. So we need to find the sum for individual digits of 100. So 1 into 1 plus 0 into 0 plus 0 into 0. So which is equal to 1 plus 0 plus 0 is equal to 1. So finally we got 1 as a result. That means a single digit, and that is also equal to 1, right? So it's a single digit, and again this is equal to 1. So that implies 19 is happy number. So if you get like this, so recursive sum of squares of individual digits until it reaches to single digit, and if that single digit is equal to 1, we call it as a happy number, right? Now we'll see the logic written in Python. So we'll write the logic in Python. So first let us read the value. So n is equal to int of input, write down, enter number, right? Now let us take one more variable and initialize that one to that particular number to that particular variable, and we have to repeat until the sum becomes single digit. So for that purpose we'll write while x greater than or equal to 10. So until this condition becomes true, the loop will be repeated. That means we will store the sum in x. So after every iteration, the x will be having the sum. And now initialize sum is equal to 0 because we need to find that. And while, so the remaining logic is same, while x is greater than 0, so we need to find the sum of squares. So first we need to find the remainder, r is equal to x mod 10. We'll get a remainder, that means an individual digit, and we have to add that to sum, so which is nothing but a power, that means a square, right? Square. So simply we can use r double star 2, which is an exponential operator. So sum will be there. Now we have to reduce the 3-digit number to 2-digit number by using x is equal to x floor division of 10. So we know all these code, right? So first instruction to find the individual digit, second instruction to find the sum of that particular square, and the third one to reduce the 3-digit to 2-digit, right? And after that, just send a sum, assign sum to x, so that it will check here whether it is a single digit or not. So if it is not a single digit, if it is a greater than or equal to 10, again the same process will be repeated for x value. So x holds the sum of current iteration. So this is a iteration. For every iteration, the sum value will be changed, and that will be assigned to x. So finally, if x is equal to 1, simply we can say it as, so n is a happy number, and else that's a false case. Simply we can print n is not a happy number, right? So if I execute here, I will go with a 19. So we'll get 19 is a happy number because we are keep on executing this one. So you can observe here, so after every iteration, you can print the sum. See, so that you will be getting clarity. See, if I go with 19, see, first sum is equal to 81, next sum is equal to 82, next sum is equal to 4, 68, 64, and finally we got the 100, right? So some 0, 0, 1 for individual digits we are writing, right? So if you place here, we will get a final sum. See, 82 is the first sum, second sum 68, third iteration we got 100, in the fourth iteration we got a 1, right? First iteration it is 82. So again we need to find the 8 square plus 2 square, which is nothing but 68. 68 again we have to use the 6 square plus 8 square, which is 100, and again we need to find 1 square plus 0 square plus 0 square, which is 1. So 19 is a happy number. And if you execute the 13, simply we will get a 10 and 1. So if you go with any other number, 45, see, so we got a single digit, but it's not a 1, right? So first sum is 41, next sum is 17, next 50, 25, 29, 85, 89, 145, 42, 20, and finally we got a single digit number, but it is not equal to 1. So that's why 45 is not a happy number, right? So hope you understood this one. If you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session we'll discuss about one more number program, that is a HARSHAD number or NIVEN number. HARSHAD number or NIVEN number. So first let us see what is this HARSHAD number, and next we'll see how to implement this one, how to find this one in Python program. So HARSHAD number or a NIVEN number, we'll call it. So if a number is divisible by its sum of individual digits, then we can call it as a HARSHAD number or NIVEN number. For example, let us take 18. 18 is a number, and you can see 18 is divided by the sum of individual digits, that is 1 plus 8. So that is equal to 2, and the remainder is 0. So we say that if the remainder is 0, that implies the number is divisible by the sum of individual digits. So now we'll see how to write the program for this one. So first let us read the input, and then we'll find the sum of individual digits of that particular number, and then finally we'll check whether the given number is divisible by the sum of digits or not. If it is divisible, we can say it as a HARSHAD number or NIVEN number. Otherwise it's not an HARSHAD number or NIVEN number. So let us implement this one. So I am reading one number, n is equal to, so integer of input and enter number. So here it will prompt for the number, and now I will take one more variable, x is equal to n, because finally we need to check whether that number is divisible by sum of digits. So I am taking one temporary variable and I am assigning the value to that particular temporary variable, and here my temporary variable is x. Now we need to find the sum of digits. So we have to repeat the process until I will take x greater than 0, because x and n holds the same value. Now first we need to find the remainder. So in order to find the remainder, so finding the remainder gives the individual digit, right, from the right to left. So r is equal to x mod 10. So this line, this instruction, if this instruction is executed, we'll get the individual digit, that is the ones position, individual digits of the ones position. Now we need to sum this particular digit, right? S is equal to s plus, or we can take sum is equal to sum plus r, and initial value of sum we will take it as a 0. Initially the sum value is 0. Now we need to reduce. So we found the digit at a 0th position, that means ones position. Now we need to change for the 10th position. So for that we have to reduce the number. So I will go with the x is equal to x divided by 10. This will reduce the number from one place. So after that we'll get the sum, and finally we have to check. So if n mod sum is equal to 0, we'll say that the number is Harshad number. Print, see, n is Harshad number, or NIVEN number. We can write anything, right? So else we can simply print n is not Harshad number or NIVEN number, right? So we can check. So 18. So 18 is a Harshad number because 18 divided by 1 plus 18, that is 9, which is a factor, right? So it is successfully divisible. So we should get it is a Harshad number. So one more example. If I take 24. So 24 divided by 2 plus 4, that means 6. So again it is divisible. So 24 is also the Harshad number. And I will go with the 35. So 3 plus 5, it is 8. So 35 divided by 8, which is not divisible. So we should get it is not a Harshad number, right? So this is how we can find whether the given number is Harshad number or NIVEN number. So the number, if the number is divisible by some of its individual digits, we can call it as a Harshad number. So hope you understood this one, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends. So just now we have seen the logic for finding the magic number. So recursively we have to sum the individual digits of a number until the sum becomes a single digit, and if that sum, the final sum, is equal to 1, then we can say it as a magic number. So first let us take one number. N is equal to int of input enter number. So we need to find this number n, and I will take one temporary variable x is equal to n, and to recursively call this one, right? So we have to repeat this one until the sum is greater than or equal to 10. So whenever the sum is greater than or equal to 10, we need to repeat the same process. That is, we have to find the sum of individual digits. So while x greater than 0, we need to find the remainder. So r is equal to some x mod 10, and we need to add that to the sum. Sum is equal to sum plus remainder, and we need to reduce the number. So x is equal to x floor division of 10, right? And finally the sum will be taken as x for the next iteration. So because we have to repeat the same process until the final sum is less than 10, right? So whenever this condition becomes true, again we need to repeat the same process. That means we need to add the number of digits, right? And finally, if the sum, the single digit sum, is equal to 1, we can simply say that it's a magic number. It's a magic number. So n is a magic number. And in the false condition, simply we can print it as not a magic number, is not a magic number, right? So if you execute this one, I will give 1, 2, 3, 4. So you can observe 1, 2, 3, 4. That means 1 plus 2 plus 3 plus 4, which is equal to 10. Again, it is a 2-digit number. So again, we need to repeat the same process until we get the sum in a single digit. Okay, less than 10. So 10, and we need to again repeat the same process and we have to add 1 and 0. The result is 1. So 1, 2, 3, 4 will be the magic number, right? And one more example. If you execute this one and let us take 12. So what is the sum of digits here? 1 plus 2, it is 3. So the sum, if the sum, final sum is equal to 1, then only we can call it as a magic number, right? So 1 and 12, we are giving 12. So 1 plus 2, it is 3. So it will not be the magic number. And similarly, 5, 2, 3. Sorry, 4, 2, 3. 5, 2, 3. So 5 plus 2 plus 3. That means 7 plus 3, 10. Again 1 plus 0, 1. So 523 is a magic number, right? So hope you understood this one. So we need to find the sum of digits recursively, so until we get the sum in a single digit. Okay, so this process we call it as a magic number. So hope you understood this one, and if you are having any doubts regarding this one, finding the magic number, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends. So just now we have seen how to find the neon number. So first we need to find out the square, and then we have to add the number of digits so that we have to get the same number. Then we can call it as a neon number. So I will execute this same thing. So let us take a number n is equal to, so int of input function. So enter value for n, so that after getting that one, find out the square. We need to find the square. So sqr is equal to n double star 2, or we can simply use n into n. Now we got a square, so now we need to find the individual digits of the square and we have to sum. So repeat the loop until a square greater than 0 and find out the remainder, so that we'll get individual digits. So digit is equal to sqr divide mod 10, and now we need to add all the digits, right? So sum is equal to sum plus digit, right? Now reduce the square. So sqr is equal to sqr floor division of 10, so that it will be reduced, right? Now this will be repeated, and finally let us take one temporary variable. So temporary is equal to sqr, and sorry, so it's not required, I think. Yeah, yes. So now if the sum value is equal to n, then we can simply say that the number is neon number, right? And if not, simply we can print it as a not a neon number, is not neon number, right? So for example, we have taken 9 as an example. So 9 is a neon number. So some sort of error has been done. Yes. So initialize sum with a 0, so that you can get a 9 is a neon number. And if you give 10, 10 is not a neon number, right? So hope you understood this one. So first we need to find out the square, and then we need to find the sum of individual digits of that particular square, so that we have to get that particular number. So then only we can say it as a neon number. So here first we are finding the square, and then we are initializing sum as 0. So we are finding the individual digits, and we are adding all those digits, and finally we are comparing this sum with the given n value. So if both are equal, we are saying that it's a neon, and otherwise it's not a neon number, right? So hope you understood this one, right? So if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really understood my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll discuss about one more programming Python, that is how to find the palindrome, a numerical palindrome, right? So let me explain you about the logic, and then we'll go with the program. So first, palindrome check. So first we need to find a reverse of a number, and then we need to compare a reverse of a number with given number, right? And if both are equal, we can say number is palindrome. And if both are not equal, both are not equal, then we can say a number is not a palindrome, right? So first we need to find the reverse of a given number. So let us take some n is equal to 151. So we have to reverse that number. In order to reverse that number, a simple logic. So we need to find the individual digits and we have to multiply and add so that we'll get the number, right? So see, r is equal to r mod 10. If you divide this one, we'll get the individual digits. That means in the first iteration, so 151 mod 10, which will give the result as a 1, right? Next, find the reverse into 10 plus r. So this is a second step. So we need to multiply and we need to add with individual digit, right? So initially take the reverse as 0, right? So after executing this step, we'll get 0 into 10 plus 1, right? So because r value is 1, right? Here the r value is 1. So we got a 1 as result, and here we'll get 1 because 0 into 10, it is nothing but 0. Next, we need to reduce the number of digits. So after completion of first one, we have to reduce the number of digits. So now there is a 3-digit number, and this 3-digit number should be reduced to 2-digit number. So for that, we have to use a mod 10. So if you use, floor division of 10. So 151 floor division of 10, which will give the result as, see, if you divide it with 151, the result will be 15.1, and floor division only integer part should be considered, so it will be 15. The result will be 15. And repeat these steps. Repeat the above 3 instructions until n greater than 0. So now n value is 15, which is nothing but greater than 0. So what we have to do? We have to repeat the same steps. Now again, r is equal to, okay, sorry, here it is not r, it's an n. Okay, yeah. So n mod 10. Again the same steps. We have to repeat the same steps. See, I'll just copy and paste it. So now n means 15. 15 mod 10. So we'll get the result as 5. Now reverse is equal to reverse. So initially the reverse, now reverse value is 1. So 1 into 10 plus 5, which is nothing but 15. And 15 floor division of 10, which will give 1, right? So hope you understood. Again, greater than 0. So again, they repeat the above instructions. So once again, we need to execute the same instructions. Now n value is a 1. So we'll get the number 1. So 1 mod 10, which is nothing but a 1. And now reverse is equal to reverse into, so 15 into 10 plus r, 1, right? And here also 1 mod 10, 1 floor division of 10, which is nothing but 0. So it's not greater than 0. So we need to stop here. Right? So here you can observe 15 into 10, 150 plus 1, 1. So after completion of these things, what is the reverse value? It's a 151, right? So here, after completion of iterations, reverse is equal to 151. Compare reverse value with n. So reverse is equal to 151 and n is equal to 151. So reverse is equal to n. That implies n is palindrome. So hope you understood this one. So these are the three steps to be required while finding the reverse of a number. So in the palindrome check, first we need to find the reverse and then we have to compare with the given value. If both are equal, we can say it is a palindrome. So here I am taking 151 as an example. So number, I am taking one reverse variable is equal to 0. So r is equal to, so this r is to finding the individual digits from one's position. Okay, so one's position, tens position, hundreds position, thousand positions, like that we have to move on. So in the first iteration 1 we got, and reverse is equal to 0, 0 into 10 plus remainder, so that means a 1. So we got 1, and we need to, after every iteration we need to reduce the n value. We have to reduce the number of digits of n value. So initially the number of digits of n value is 3. After first iteration we have to reduce it to 2 digit, right? And then again repeat the same process, okay, because n has been modified. So repeat the same process so that we'll get until the n value is greater than 0, and finally we'll get the reverse value. So compare this reverse value with the given number. If both are equal, simply we can say it is a palindrome. Hope you understood this one. And now I will write down the logic. See, let us take an value. So n is equal to int of input enter number, and I will take one temporary value, some temp or x, will take x is equal to n. So the same value has been given to x because in every iteration we are updating the n value. So finally we have to compare with the given value. So for that purpose we are just giving one variable with assigning the same value. So now while x greater than 0, so we have to repeat the statements until the x greater than 0. Now I am considering it as x, right? So the original value is in n. Now find out the remainder. Remainder is equal to n mod 10. We'll get a remainder, and then reverse is equal to reverse into 10 plus r. So we have to reduce the number of digits. So n is equal to n floor division of 10, and initially take the reverse value as 0, right? So we will get the reverse of a number. So just print it. Print reverse of given number is, we had a result in reverse. So now compare. If reverse is equal to n, simply you can print n is a palindrome, else print n is not a palindrome, right? Now execute. I'll go with 1 2 3. Okay, sorry, it's moving into the division. So x, so it went to the infinite loop because we are just dividing the n value, but we are comparing with the x value. So always the x value will be greater than 0. So that's why it will moving on the infinite numbers. Okay, now you can see 1 2 3. So reverse of a given number is 3 3 3. What is this? Here also it is x. Okay, now let us check. So 1 2 3, and it is 321. Yes, so 321, right? So we are just taking the x value because finally we have to compare with the given value. So that's why I am assigning the value to the x. So we have to iterate with the x or n. So either you have to use a x or you have to use a n. If you are using n, then here we will compare with x. Okay, if you are using x, here we'll be comparing with n. So previously by mistake I have used that n value, right, instead of x, but here in the condition I have used the x, and in the instructions I have used the n value. So that's why we got an error. So now it's clear. So first we are finding the reverse of a given number. So 123, the reverse of a given number is 321, which is not a palindrome. Let us take 121. So reverse of a given number is 121, and so 121 is a palindrome, right? So this is how we can simply find the palindrome. Simply we can find the palindrome check. Okay, so hope you understood this one, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. In today's session we'll discuss about the perfect number. So how we can find a number as a perfect or not. So first let us see the logic, and then we'll implement the same thing using Python language. So perfect number. A number which is equal to sum of all its factors except given number is known as perfect number, right? So first we have to find all the factors, and then we have to perform the addition of those factors, and we have to compare that with the given number. So let us take an example. So let us take n is equal to 6. So what are the factors of 6? So the factors of 6 are 1, 2, 3 and 6, right? So we should not consider that number, given number, right? So that's what we have done. So a number which is equal to sum of all its factors except a given number is known as a perfect number. So sum of factors, you have to add all those factors, 1 plus 2 plus 3, which is equal to 6. So this is nothing but given number, right? So that's why we can say 6 is perfect number. So how to find these factors? So simply, so finding the factors means simply you can perform the mod operation. So if the mod operation is 0, that implies it's a factor. For example, you can see finding factors. So 6 mod 1, 6 mod 2, 6 mod 3, 6 mod 4, 6 mod 5. So we should not consider 6 mod 6. Okay, so we should not consider that one. So 1 mod 6 is equal to 0, and see 6 mod 2 is equal to 0, because so 6 is divisible by 2, right? Next 6 mod, sorry, we have already written this one. So 6 mod 3 is equal to 0, 6 mod 4 is equal to 2, 6 mod 5 is equal to 1, right? So we can say if we perform the mod operation and we got 0, those numbers we can consider as a factors, right? So 6 is divisible by 2, 6 is divisible by 3, 6 is divisible by 1. And coming to this one, 6 is not divisible by 4, since 6 is not divisible by 5, because the mod operation is not this one. So we have to consider only these 3 things. 1, 2, 3 are the factors of 6, right? So I will write here finding factors, right? So we have first we need to find the factors, and then we have to add the factors, and we have to compare the factors, the sum of all the factors with given number, right? So hope you understood this one. So consider n and we have to iterate. Okay, we have to iterate that number from 1 to n minus 1, and we have to consider only the numbers which are the factors of this one, this particular number. So to for which we got this mod, right? So let's execute the program here. So I will take n, a number, and which we need to find for the perfect number. So enter number, enter number, right? Now, so what we have to do, we have to iterate. So for I in range of 1 to n. So if you consider n, so it will not be considered because n is a n value in the range function which is not included, right? So that's why we can iterate from 1 to n. So the last number should not be calculated, right? Now what we have to do, we have to check whether the mod operation is 0 or not. Okay, and we have to consider only them. So I will take if n mod I is equal to 0. What we have to do, we have to add them, right? So sum is equal to sum plus I, because the factor is this one and we have to add them, and simply finally compare this one sum with n. If both are equal, we can print n is a perfect number. And in the false case, if the sum is not equal to n, we can simply consider n is not a perfect number, right? So initially we will take sum as 0, right? So enter, give the 6. So 6 is a perfect number because the factors of 6 are, so what are the factors? So 1, 2 and 3. And if you execute this one, so what we'll get, again 28, it's also a factor. See, here we'll print the value. See, if I go with the 6, the factors are 1, 2, 3, and yes, I will give the new line character here, so that 1, 2, 3. So the factors, and here also I will give a /n new line character. So if you go with the 6, see 1, 2, 3. Okay, and n is the perfect number. N is a perfect number. So just for presentation itself, we can give so see 1, 2, 3 and 6 is a perfect number, right? So if you consider some 28, so these are the perfect numbers. I mean, these are the factors, and if you add this one, we'll get a 28. If you add this one, we'll get this 28. And also you can go with the one more number, 64, and see if you add all these things, it doesn't matches with the 64, so 64 is not a perfect number. Okay, so hope you understood about this perfect number. First we need to find out all the factors and add all the factors, and if the sum of all the factors is equal to the given number, we can say that that particular number is a perfect number, right? So hope you understood this one, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll discuss about how to find the prime factors. So all of you know about the factors, right? So now our program is to find the prime factors. So Let us see the logic and then we'll go with the implementation. Prime factors. So first thing, we need to find factors of a given number. Second thing, find prime find each factor for a prime number, right? So prime check each and every factor, find each factor for a prime number. So this is a simple thing. So factor check. So how to check the factors means, so divide the number with from 1 to given number, right? And if modulo operator results 0, that means the number is factor. Okay, the number is factor of a given number. So so that means we have to apply the modulo operator from 1 to that particular given number, right? Let us take some given number means n. So we'll take n. So if modulo operator results 0, that means the number of is a factor of n. Divide n from 1 to n. Okay, so divide n from 1 to n. And if modulo operator results 0, that means the number is a factor of n. Right. Now prime check, what we have to do for the prime check, apply the same thing, divide the factor from 2 to n minus 1, because if any number is having a factor of 1 and itself, so that means the prime number will be having the factors only 1 and itself. So we are eliminating both the things. So we are checking for from 2 to n minus 1. 2 to n minus 1. Right? If there is any factor, so simply we can say it is not a prime. Right? So there should not be factor from 2 to n minus 1. Then we can say it as a prime, right? So let us check with the implementation part. We'll see the implementation part. Okay, so first let us take an n value. So n is equal to int of input enter number. So we are taking some number. Now we have to find the factors. For each factor, again we have to check for the palindrome. So for I in range of 1 to n plus 1. So here we are writing n plus 1 because we have to check for the self also, right? N plus 1. And what happens if n is divided by I? That means every iteration I value will be changing from 1, 2, 3 and so on till n plus 1. If n mod I is equal to 0, that implies it is a factor. It is a factor. Now we have to check for the prime. So for j in range of 2 to what is here prime, we have to check the prime for I. So 2 to I, if I mod j is equal to 0, simply initialize the flag to 1 and initially take the flag as 0. So change the flag value as 1 because it is having a factor and break the chain, right? Break the chain, and after that come out from the loop, and here based upon the flag value, so flag is equal to 0, that implies it is a prime. So print, what we have to print I, so I value, and use a end attribute so that the next output will also be print in the same line itself, right? For example, this is a program, simple program. Execute this one and take 24. So we know the factors of 24: 1, 2, 3, 4, and 6. So among that, only 1, 2, 3 are the prime factors. So if you execute, you'll get only the prime factors. So if you consider any other number, so if you consider some 4 ones, so we are having a lot of factors, but we are having the prime factors are 1, 11, and 101. You consider 99. So the prime factors are 1, 3, and 11, right? 1, 3, and 11. Similarly, let us take 100. So the prime factors are only 1, 2, 5. So simple logic. First we are checking the factors. So if n mod I is equal to 0, that implies n is divisible by I. So factor of n is I. So we need to check for prime for this particular I value. So that's why we are taking one more iteration. We are dividing that particular I value with j value. So j ranges from 2 to I, because that means 2 to I minus 1 it will iterate. So if there is any factor for this particular number, automatically the loop will be terminated, and based upon the flag value we are deciding whether it is a prime or not, because if it is a prime, the flag value remains same. That means the flag value will not be changed. Initially flag value has been taken as 0, so only if it is having a factor, the flag value will be changed to 1. If the flag value is 0 after completion of all the iterations, simply we can say the number is a prime number. So it moves to the next one. I will be second one. So again it will check for the prime factor. Again if it is again it will check for the factor, and if it is a factor, again that particular value will be checked for the prime. So this is a prime logic. This is a factor logic, right? So it's a very simple. So hope you understood this one, and if you are having any doubts regarding this prime factors, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. In today's session, we'll discuss about the prime check program in Python. So first of all, let us see what is a prime number, and then we'll see the logic. So how to find the number is a prime or not. So how many of you know about the prime number? So once again I will repeat the logic. Prime number, right? So a number is called a prime number. So a number which is divisible by 1 and itself is called prime number, right? So we need to find the prime number. So what we have to do? So we need to divide that prime number from 2 to n minus 1. For example, if n is a number, then n should be divided from 2 to n minus 1, right? If any number is divisible by n, okay, between 2 to n minus 1, so we can say it is not a prime. Otherwise it is a prime, right? It is prime. So for this one, we'll take one control variable, a loop variable iterates from 2 to n minus 1. 2 to n minus 1, right? And how to know whether the number is divisible? So mod operator is used to find the factor. So factor means which is divisible by the number, right? So by using this logic we'll use, for example, let us take an example, some n is equal to 5. So if it is n is equal to 5, so that number should be divisible by n. We need to check n mod, yes, 5 mod 2, 5 mod 3, 5 mod 4. So if any one results 0, then it is not a prime, right? But here it doesn't, any one doesn't result 0, right? So in this case it doesn't result the 0. Doesn't result 0, then it is a prime because it doesn't have any factors. So we are checking from 2 to n minus 1, 2 to n minus 1, right? See, let's move on to the logic. So let us take a number n is equal to n input, enter number, and now we need to check. So we will iterate. Okay, so for I will take one loop variable I. In range we have to start with the 2 to n minus 1. So in the range function, if you use n as a upper bound, so it doesn't evaluate the n, so it will evaluate till n minus 1, it will iterate till n minus 1. So 2 to n, and here we will have to check if n mod I is equal to 0, simply we can print n is not a prime, right? And in any condition, in any number, if any number is divisible by that particular loop variable, it is prime. So we can simply break, we need not iterate the next numbers, right? Then else, if doesn't results to 0, simply we can print n is prime. Okay, hope you understood. So we can write the else part in Python for the iterative statements also. If this condition fails, okay, if this condition fails, automatically the else part will be get executed. So if it doesn't execute this one, automatically the else part will be executed and it is prime. So whenever the mod operator is 0, that means these are the factors, there are factors for that particular number, but the prime number will be having a factors of 1 and itself, but we are excluding the both. So we are excluding 1 and n, so we are iterating from 2 to n minus 1, right? So execute this one, go to the 10. So 10 is not prime because we are having a factors, right? Simply you can print here. See, if you go with the 10, so we are having some factors. Okay, so 2, okay, 10 mod 2 is equal to 0, automatically it will print 2 and break. So if you are not using this break statement, we'll get all the factors 2, 5 and 10, 2, 5 and 10, right? So we are using, if any one of the thing is 0, if there is a factor, any one factor, simply we'll get it's not a prime. Okay, so one more example, execute some 15. 15 is not a prime because it is having a factors 3, 5 and 15. So go to the 1, 1, 1, 1, 4 ones. So it's not a prime. Maybe it has a factor. Simply we can see which one is a factor, the first factor, which one is a first factor. So 1, 1, 1. So 11 is the first factor, right? So that's why we got n is not a prime. So hope you understood. This is a simple program to find whether the given number is a prime or not. So if you are having any doubts, so feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll see how to find the prime palindrome. So first we'll see the logic and then we'll go for implementation. So we need to check a prime palindrome. So this is a combination of two programs. So the first one, we need to check whether number is prime or not. Second step, if number is prime, then we have to check for palindrome, right? If it is palindrome, we can say number is prime palindrome. So this is the thing. So first we need to check for the prime, and the second thing, if the number is prime, then we have to check for palindrome. If it is not prime, we need not go for the step 2. Here we will stop. Okay, and here we need to check for the palindrome, and if it is also palindrome, we can say the number is a palindrome, prime palindrome. So prime check. So how to find the prime check? So first we need to iterate dividing number with from 2 to n minus 1, right? And there should not be factors for the given number. Then we can say it is a palindrome, right? Next, prime check. Next, palindrome check. So what we have to do in the palindrome check? So first we need to find reverse, because the palindrome means if the reverse, if the number, if you find the reverse of a number and that is equal to the given number, then we call it as a palindrome, right? So that's why the first step is we need to find the reverse of a given number. Reverse of number. Second, we need to compare given number and reverse of number. Third, if both are equal, we can say it as a palindrome. So we need to check both the things. So first we need to check whether its number is a prime, and then if it is prime, then only we will go with the palindrome. Now we'll start implementing the thing by using a Python. So first let me take a number n is equal to typecast int input enter number, right? So now n is having a number. Now I just want to find whether it is a prime or not. The first step is prime. So I will give the command here, prime check program. Now, so we need to iterate for I in a range of 2 to n. What we have to do? We have to check whether there are having any factors or not. So that means we have to divide that number with I, that means a mod. If it is equal to 0 in any case, that implies it is having some factors. So if it is true, simply initialize the flag as 1. So initialize the flag as 0. So initially change the flag as 1 and break the loop, because if there is any one factor for the given number, so simply we can say it is not a prime. So after that, compare this one. So based upon the flag you can compare. So if flag is equal to 1, so print n is not a prime. N is not a prime, right? Next, in the false condition, else if it is prime, now we have to check the palindrome, right? So n is prime, and now we need to check the palindrome. So I will give the comment here, it is a palindrome check. So we have done the two programs individually, but now in this program we are combining both the things, prime and palindrome. Now we need to write down the, first we need to find the reverse of a number. So for that I will take one more variable and assign the n value for x, because in the further instructions we are going to update the n value. So after that we have to find the reverse number and we need to check for the given number. So that's why we are taking a one extra variable, some x is equal to n, and we have to iterate. So we have to iterate while n greater than 0 until the n greater than 0. So we need to find the remainder r is equal to some x. Okay, let us take some x here. So x mod 0, x mod 10. So we'll get individual digit, and then we have to add it to a sum into 10 plus the remainder, and finally we need to reduce the number of digits. X is equal to x double floor division of 10, and simply we can check here if the sum is equal to n. Simply we can say it as palindrome, prime palindrome. So n is a prime palindrome. So if it is not correct, simply you here print n is not a prime palindrome, right? So I'm executing this one. So let us check whether there is an error or not. So I will take 151, which is a prime number. 151 is a prime number. Let us check here. So 151 is a prime, and there is a sum problem. So sum, yes. So we are updating the sum, and but we are not given, we have not initialized the sum with any value. So I am initializing the sum value with 0. Now let us check again. 151. So 151 is a prime and 151 is a prime palindrome. Let us go with this one. So 111. So 111 is not a prime. Okay, it's not a prime because it is having some factors. 111 is having some factors, right? So what are those factors? You simply print here, so that we'll get 111. So 3 is a factor. So 111 can be divided by 3. Okay, so once again execute this one, and 171, so which is also not a prime, it's also divided by 3. So like this we can check whether the given number is a prime palindrome or not. Okay, so first we need to check the prime. If it is yes, then only we will check for the palindrome. If it is not prime, it's not necessary to find the palindrome check, right? So for palindrome also, first we need to find the reverse of a number, and then we have to compare that number with a given number, reverse of a number with a given number. If both are same, we can say it is a palindrome. So initially we have checked with the prime, so it is a prime palindrome, right? So hope you understood this one. See, 11 is also a prime, and it's a prime palindrome. Yes. So hope you understood this one, a simple logic. And if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll discuss about how to find the prime series. That means we'll give the starting number and the end number. We are supposed to find all the primes in between the given range. So first we'll see the logic, and then we'll implement that by using the Python language. So prime series, right? So first let us find about the prime. If you take a value n, so what we have to do, n should be, we have to find the factors. Okay, find the factors. So it should be divided by from 2 onwards, because every number will be divisible by 1 and itself. So we have to find the factors. That means divisible, we have to check the divisibility from 2 to n minus 1, right? From 2 to n minus 1. So we need, if you take n as a value, so we have to find n divided by n mod 2, n mod 3, n mod 4, and so on, n mod n minus 1. right? So we should not get this divisibility. That means we should not get a 0 for all these operations. So then only we can say n as a prime number. Now we have to, this is for a prime logic. Okay, this is for a prime logic. So if you want to take the prime series, right? Prime series, so we need to consider the start range and end value. Okay, starting value and end value, we need to find the prime numbers in between those values. So for that, we'll take the start number. So two loops should be taken. One is a outer loop, so which will be iterating from start value to end value, and inner loop, we'll write an inner loop, so where we have to find the divisibility for each number from outer loop, right? So whatever the number we are getting from the outer loop, we have to find the divisibility for each number from 2 to the number minus 1. So this is the number which is coming from outer loop, right? And the rest of the thing is same. So the prime number means a number which is having the factors 1 and itself. That means the divisibility 1 and itself. So for all the other numbers, we should not get the 0 if we apply the mod operation. Then we can say that it is not divisible by particular number. Now, so we'll write the logic. See, let us take the start value. Start value is take the integer value, input, enter starting value, and similarly we have to go with the end value. So int of input, enter end value. Now we have to write two loops. One is an outer loop for ranging starting value to end value. So for I in range start to stop, or here we have taken it as end, right? End. And now we have to check whether the number is prime. I is a number now, right? I is a number now. So write down the prime logic. So once again, repeat the one more loop for j in range. So what we have to do, we have to check the divisibility from 2 to that particular number. So for every iteration, the number will be in I. So we have to iterate from 2 to I. And by what we have to do, if so I mod j. So for if we have taken the start value as 5, the 5 will be taken, and j value is from 2, 3 and 4. So 5 divided by 2, 5 divided by 3, 5 divided by 4, right? So like that we have to take, and if it is 0, simply we can break, and else simply we can print the I value so that it is a prime. So if it is not 0, that means, so in all the iteration, that means the j coming from 2 to I minus 1, if any number, okay, if any number is not divisible, so automatically this part will be get executed. So we are printing I because it is a prime number. So I am using the end attribute so that the next output will be printed in the same line. So this is a simple logic for prime series. Okay, this is a simple logic for prime series. We'll check. See, I'm executing. So I'm taking the starting value as a 10 and end value as 100. That means I am supposed to find the prime numbers in between 10 to 100. So the outer loop will iterate from 10 to 100. So in each and every iteration, the value will be incremented by 1. So initially the value is 10, and for j in range 2 to I, that means 2 to 10. So we have to divide this 10 with the numbers 2 to 9, because the range function doesn't include the n value. So it will iterate from 2 to I minus 1. That means here 9, 2 to 9. So here it will iterate 10 mod 2, 10 mod 3, 10 mod yes, 10 mod 4, 10 mod 5, so like that it will be iterating. So whenever the first iteration 10 mod 2 is equal to 0, so obviously it is not a prime because there is a factor. So automatically break, it will come out from the loop and the next iteration will be getting. So 11. Now the 11 will be iterated from 2 to I minus 1. That means 2 to 11 minus 1, 10. So in the first iteration of J, the 11 will be divided by 2, so it is not equal to 0. It will be iterated next one. So 11 will be 11 divided by 3, 11 divided by 4, 11 divided by 5, and so on. It will move on to 11 divided by 10. So none of the cases it becomes 0, so automatically this will be executed and 11 will be printed here because 11 is a prime number. So if I execute this one, see, we'll get all the primes 11, and in the next iteration 12 mod 2 is equal to 0, so true. So 12 is having a factor, that implies 12 is not a prime, so break. It will move on to the next iteration, right? It will come out from the loop, inner loop. So next iteration 13, so 13 will be divided with all the numbers from 2 to 13 minus 1, 12, right? So in none of the cases it becomes 0, so automatically this else part will be printed. So I will be printed 13. Next is 17, 19, 23, 29, and so on. So we'll get the prime series from given number to, I mean, in the given range. For example, if you go with the value, starting value 1, and if you go with the 1000, we'll get all the prime numbers from 1 to 1000. Right? So this is a very simple. So this is a previous logic to find the prime, and we are just adding the outer loop with a start value and an end value. So we are giving the range in which we want to find the prime, right? So hope you understood this one. So if you are having any doubt regarding this program, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends. So just now we have seen the logic to find the PRONIC number. Now we'll implement the same in Python. First let us read the integer value. So int, we have to use an input function to read the integer, enter a number n, right? And after that we need to iterate the statements from 1 to n plus 1, and we need to find out the each and every product of consecutive numbers. If I into I plus 1 is equal to n, simply just initialize the flag as 1 and take the flag initially as 0, right? And after making the flag 1, simply break, because if there is a true statement, simply we can break the loop. And finally find that if a flag is equal to 1, so simply we can say n value is a PRONIC number, else simply we can call it as a non-PRONIC number, right? So is not a PRONIC number, right? So hope you understood. We are iterating the values from 1 to n plus 1, and we are finding the product of all the consecutive numbers, and we are comparing with the n. So if any one case is a true, simply we are just initializing the flag value as a 1, and we are just coming out from the loop by using the break statement. So if there is no match for all the cases, simply the flag will be remains 0. So finally, after completion of the iterative statements, we will check the flag value, and based upon the flag value, we are deciding whether the number is a PRONIC or non-PRONIC. So we will execute. So okay, I in range, yes. So I'll take some 6. So 6 is a PRONIC number, yes, because 6 is a product of 2 and 3. 10. So 10 is a not a PRONIC number, because the 10 is a product of 5 and 2, which are not a consecutive numbers. And again 12 is a PRONIC number because it is a product of 3 and 4, right? Similarly 20. It's also a Pronic number because it's also a consecutive, the product of consecutive numbers 4 and 5. So this is how we can find whether the given number is a Pronic or not in Python. So hope you understood this one. And if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. In today's session, we'll see one more program in Python, that is a special number. So how to find whether the given number is a special number or not. So for this, first we'll discuss about how to find that, and then we'll see the logic implementing in Python. So if the sum of factorial of individual digits of given number is equal to a number, given number, then we call it as a special number, right? So sum of factorial of individual digits of a number. Then let us see the example so that you will be understanding perfectly. So let us take n is equal to 145. So what are the sum? Sum is equal to 1 factorial plus 4 factorial plus 5 factorial. So which is equal to 1 factorial is 1 plus 4 factorial is 24 plus 5 factorial is 120, and if you sum all these three, so we'll get the number as 145, which is nothing but n value. So simply we can say 145 is special number. So what we have to do, we have to find out the individual digits, and we have to apply the factorial for that individual digits, and we have to update the sum. That means we have to add all those factorials of individual digits, so that we have to compare with the given number. If both are equal, we can say simply it is a special number, right? So hope you understood this logic. Now let's implement in Python. So first let us read the number. So n is equal to int of input enter number. So what we have to do then, I will just copy this n value to one more variable. Let it be x is equal to n, because so after updating, I mean in the process of finding the individual digits, we are updating the n value, and after completion of these iterations, we have to compare the sum with the given value. So that I am just taking one more variable, assigning the same value to that particular variable. Now, in order to find the individual digits, simply go with this one. So if while x greater than 0, simply find out the remainder so that we'll get the individual digits. So r is equal to x mod 10, and we have to add to the all the factorials, right? So sum is equal to sum plus factorial of r. R is the individual digits, right? Now update the x value so that it will reduce the number of digits. So if x is having 3-digit number, after first iteration it becomes a 2-digit number. So for that we have to use a floor division. So x floor division 10. Now we have to compare the sum with the given number n, because we have taken x and we are updated x. So we have to compare the sum with n, and if both are equal, simply we can say n is special number, and if not, simply we can decide n is not a special number, So is the program complete? No. So because we have to write the definition for factorial. So here we are passing one argument to the factorial function, so we need to write some user defined function. So I'll write the user defined function here, def. So factorial of r, and I will write the recursive function. So if r is equal to 0 or r is equal to 1, simply return 1, else write the recursive function. So return, we have to return r into fact of r minus 1, right? So this step gives the individual digits, and this step goes to the user defined function. It finds the factorial and it will update to the sum. So here we are updating the sum, and by default we have to consider the sum as 0, because without having the value we can't update the value. So initially the sum is equal to 0, and after finding the factorial of each and every digit, we are adding that number to the sum, right? So let us execute the program. Let us take the same example, 145. So we can see if 145 is a special number, and consider one more thing, 1 2 3, it's not a special number, because 1 factorial plus 2 factorial plus 3 factorial, 1 plus 2 plus 6, it's 9. So 9 is not equal to 123. So that's why 123 is not a special number, right? So finding the individual digits and finding the factorials, right? So hope you understood this one. So if you are having any doubts regarding this special number program, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll find the logic for spine number. Spine number. So if you consider any number, so how can we find that number is a spine number or not? So in order to find that, what is meant by a spine number, right? If the sum of all individual digits and product of all individual digits are equal, then we can say this number is a spine number. So we need to find the individual digits, and then we have to find the sum of all individual digits as well as the product of all the individual digits, right? So for example, consider an example. So 1124, you sum all the individual digits, 1 plus 1 plus 2 plus 4, so which will give 8, and product all the individual digits, 1 into 1 into 2 into 4, it is also 8. So both are equal. So we can say this as a spine number. Another example, so 132, so add all the individual numbers, which is 6, and product all the individual numbers, which is again 6. So 132 is also a spine number. So if the sum of all individual digits is equal to the product of all individual digits, then we call it as a spine number. So what we have to find out first? So initially we need to find the individual digits. Steps. So first step, find individual digits. So in order to find the individual digits, what we have to do? So n mod 10 will give the digit. Okay, it starts from the ones place. Okay, it starts from the ones place. And finally, in order to reduce the number for the next iteration, it will be n double mod 10. Okay, this is a floor division. So this will use to reduce the number. Right? So for Python we are supposed to use this one, and in other languages we'll use n divided by 10. Right? So we can use any one. So we can use a floor division or the normal division operator. Right? So first we need to find the individual digits, and then in the second step we need to find sum and product of all the individual digits. So one more way we can also find this spine number, that is, take the input as a string, okay, and iterate it so that we'll get individual digits, right? So convert that into an integer. For example, n is equal to 123. Simply, so this is of a string format. So for I in n, simply what we have to do, sum is equal to sum plus int of I. Similarly, product is equal to product into int of I. So simply we can get the result. Okay, we can get the sum and product. We need not go with mod operator, we need not go with a floor division. But if you are attempting in the competitive exam, so competitive coding, so just my suggestion is to avoid these type of functions. So write down the logic, because so if you use the functions, automatically the execution time will be more in Python. Right, the execution time will be more, and you may get the time exceed problem. So that's why, so always you just prefer to write the logic instead of using the functions, built-in functions. Okay, when you are writing the competitive exams. Right, so hope you understood this one. So first we need to find the individual digits, and the second step we need to find the sum and product of all the individual digits. So let's move on to the system, and I will execute the same logic in Python. Right, so you can use the same logic in C or C++ or Java, whatever it may be, but I will execute the program by using a Python language. Right, so let's move on to the system, and I will show you the execution. Hello friends, so just now we have seen the logic for a SPI number. So in order to find the number is a SPI number or not, we need to find the sum of individual digits and the product of individual digits. So let us execute the same thing while by using the Python. So first let us take the input n is equal to, so take down the integer, so input of enter number, right? So this will be in the integer format, so that we have to do the logic. So just do the logic, repeat the instructions until n greater than 0, so that find out the remainder, that is a digit. So digit is equal to, so n mod 10, so that you will get the ones position inside the digit. And now you need to add sum is equal to sum plus digit. So initially the sum value should be 0. Okay, initially the sum value should be 0. So outside the loop we have to declare this one. So sum is equal to 0, and then what we have to do, next one is a product. So product is equal to, so here product plus, sorry, product into digit. Okay, product into digit. Let us take some yeah, and also give the product as 1, because we are doing the multiplication. If you initialize the product as 0, so the product always will be 0, because the multiplication of 0 is 0. Now we have to, after performing all these things, you need to reduce the n value, so that n is equal to n floor division 10, and we need to compare with the same value. Sorry, we have to compare both the sum and product, right? So after completion of this, just find out the sum and product. If sum is equal to product, so simply we can say it is a SPI number. Given number is a SPI number. So let us take here, what is this one, the number. So let us take here a temporary value which is equal to n, so that we will be having the value in temp, right? So temp is a SPI number, right? Then if it is not equal to, then write down the else part. So we can simply write it as, so temp is not a SPI number, right? So if you execute this one, I will take 1124. So you can say that the 1124 is a SPI number, right? And if you take 123, it is also a SPI number. If you take some 12, so it's not a SPI number, right? Because sum of 12 is, what is it, 3, right? A product of 12 is 2. So that's why both sum and product are not equal. So that's why we get it's not a SPI number, right? So this is how we have to find out the SPI number. So if the sum of all individual digits is equal to product of all individual digits of a given number, then we can say that number is a SPI number. Otherwise we can say it is not a SPI number. Hello friends, welcome back to our channel. So in today's session, we'll discuss about one program that is to find the given number is a strong number or not. So first let us see the logic for this strong number so that we can implement the same thing in your own language. If you want to implement in C language, use the syntax for C language. And if you want to implement in Python, you use the syntax for Python, right? But the logic will be same. So first, what is a strong number and how can we identify the number is a strong number or not? So if any number, consider any number, and if the sum of a factorial of individual digits is equal to given number, then we can say it as a strong number. For example, consider 145, right? So we need to check whether 145 is a strong number or not. So what is the individual digits here? 1, 4 and 5. So first we need to find the individual digits. Then apply the factorial. 1 factorial, 4 factorial and a 5 factorial. So that's the second step. That means the first thing, identify individual digits. First step. Second step, find the factorial. Find the factorial for digits. Next, sum these factorials. So 1 factorial plus 4 factorial plus 5 factorial. Sum all the factorial of individual digits. So like this we need to apply and we need to check whether the sum is equal to the given number. For example, so this is 1 plus 24 plus 120. So which is nothing but 145. So that is the same number, right? So identify the individual digits, find the factorial and add the sum. So these are the 3 steps we need to do, and we know that. So in order to identify the individual digits, okay, in order to identify the individual digits, what we have to do? So if you want to get a 5, so simply consider this as a n, apply this one, n mod 10 will give the last digit, right? So always n mod 10, it will give last digit, that is nothing but units position. So just remember this one, because if you are trying to solve the palindrome program or Armstrong program or number reverse, right? So this will be useful. So n mod 10, if you apply the mod operator for any number, you will get the units position. Okay, and in order to reduce this number, right, use this one and divided by 10 to reduce the number. So what happens here? So first, if you apply this n mod 10, we'll get a 5, and if you reduce this one, 145 divided by 10, 145 divided by 10, right? So we'll get 114, only 14, right? So in C language we'll get the integer value. If it is Python, we have to use n/10 to get an integer value. Okay, because if it is a version 3, we have to use the floor division to get the integer value. So in the second iteration it will be 14. Again apply the same thing, so we'll get 4. Again you divide 10, you will get a 1, right? So you have to repeat the same process, and after finding this one, you need to find the factorial for this particular digit. So how to find the factorial? So start with the 1 Okay, multiply this till that number, particular number, right? So 1 into 2 into 3 into 4 into 5. So if you want to get a 5 factorial, just simply multiply from 1 to that particular number, right? So this you have to you can implement by using either for loop or a while loop, whatever it may be. Okay, any loop, you can use any loop, right? So this is how, and after that you need to sum all the values, all these factorials. So for example, if you find this 5 factorial, we'll get some 120, and again in the second iteration we'll get a 4, so 4 factorial we'll get a 24, in the third iteration we'll get a 1, it will be 1. So totally sum, directly apply the sum, so that you will get 145, which is the given number, right? So this is the logic to find the strong number, whether the number is a strong number or not. So you can implement this logic using either C language or a C++ or a Python, whatever it may be. Use the corresponding syntaxes. Now let's move on to the system, and I will show you executing the same thing by using Python. So we'll use a Python interpreter, and I will execute all these logics, and I will show you so how we can check whether the given number is a strong number or not. So let's move on to the system. Hello friends. So just now we have seen the logic to find whether the number is a strong number or not. Now we'll write a program for that. So let us take one input, that's a number. So n is equal to, take that input. So in order to take the input in a Python, so use the input function. So I'm using the input function enter number, right? So after taking the input, just copy this input to one temporary variable, because in further concepts we are supposed to change the n value, and finally we have to compare the sum with this particular number, right? So I will go with the temp is equal to n. So temp will be having the same value as n having, right? Now we have to repeat the steps, right? First we need to find out the individual digits. So for that we need to repeat the steps until n greater than 0, and find out the remainder. In order to get the remainder, what we have to do? So n mod 10. So automatically it will give the remainder. So let us print this remainder. So print digits. We'll get the digits, right? So digits. Now you can observe. So let us execute this one, and we'll see. So we have to update the n value. N is equal to n floor division 10, so that in the next iteration it will reduce, the number will be reduced to 2 digits, then 3 digits, 1 digit, right? If it starts with the 4 digits, after first iteration it will come with the 3 digits, next 2 digits, next 1 digit, right? Now execute this one. I will go with 1 2 3. So it was not printed, so just wait. So here we are not printing here, so digits is equal to remainder. Now you will get 1 2 3. See, in the first iteration we are getting 3, second iteration we are getting 2, and third iteration we are getting 1. So what we have to do now, we need to find the factorial for this particular 3. So what I have to do here, so for I in a range of 1 to remainder plus 1, right? Remainder plus 1. So what we have to do, so factorial, some variable factorial is equal to some factorial into I. So initially the factorial value should be 1, right? So for after every iteration the factorial will be 1. So initially the factorial will start with 1. So from 1 we are just multiplying to that particular number. In the range function we need to give remainder plus 1, because we have to consider the remainder value also. So here remainder is nothing but our digit, okay? Or simply you can go with the digit, don't get confused. So simply use the digit. So digit I in range 1 to fact is equal to fact plus 1. Now you can observe here, so after completion of this one, print factorial. So you can simply use this one factorial and use this one. So you can observe no, it's, so here it is a remainder, so it is nothing but digit, we have changed it just now. So 1 2 3, you can observe the digit is 3, factorial is 6 after first iteration. In the second iteration 2, the digit is 2, the factorial is 2. Digit is 1 and factorial is 1, right? So if you go with another number, some 2, 3, 4, you can observe the first is a 4, 4 factorial 24. Next 3, 3 factorial 6, 2, 2 factorial 2. So we got this factorial. So after that, what we have to do? So simply you have to sum. Okay, apply the sum. So simply use sum is equal to sum plus factorial. Sum plus factorial. Right? So you can observe here, just print some value. So 1, 2, 3. You can, oh sorry. So initially we have not taken the sum value. I will take sum is equal to 0. So 1, 2, 3. So you'll get a 3, 6, sum is equal to 6. Next digit is 2, 2 factorial is 2, sum is 8. So 6 plus 2, 8. So digits is 1, factorial is 1, and sum is 9. 8 plus 1, 9. So finally we'll get this 9, we'll get this sum, and this sum should be compared with the given number, right? Now, what we have to do? So just compare. So come outside from the loop. Now compare if sum is equal to temp. Okay, so in the temporary we are having n, because after this n value will be 0, right? So sum print temp is strong number, and if not, go to the else part, that is a false part. Simply print temp is not a strong number, right? So if you execute, so 1, 4, 5, simply first digit is 5, the factorial is 120, and sum is equal to 120. Okay, and digit is equal to 4, factorial is 24, and now the sum will be 120 plus 24, 144. Now digit is equal to 1, factorial is equal to 1, and the sum value is 145, which is nothing but a temporary value. So the given value, that is a strong number. Now you can remove all these digits, right? So because don't get confused, so in order to understand, I have just used this output statements. So for every iteration, I just want to show you the digits, the factorial, and the sum, what is the sum value and everything. So I'm not considering these output statements. Now you can simply go with 145. So directly we'll get the result 145 is a strong number, and simply go with the 123, which is not a strong number, because the sum of factorial of all these things will be 8, not the same number, right? So this is how we can find whether the number is a strong number or not. So I am using this Python to implement this one, and you can use any other programming languages and use the corresponding syntaxes, and the logic is same. First you need to find the individual digits, and then you have to find the factorial for the individual digits, and finally add all the factorials so that we have to get the given number. So if not, the number is not a strong number. Welcome back to our channel. In today's session, we will discuss about one more program in Python, that is to find whether the number is a sunny number or not. Sunny number. So first we'll see the logic, then we'll go with the program. So a number is called as a sunny number if immediate number is a perfect square, right? So let me explain. So consider n value as a 3, so that what is the immediate number? So immediate number is, for this number 3 is 4, which is nothing but a perfect square. So how we can say it is a perfect square? So it is nothing but a 2 into 2, right? See, if n is equal to 4, so the immediate number is, what's the immediate number? 5. So after 4 we will get a 5. So which is not a perfect square. So if it is a perfect square, then we call it as a sunny number. So 3 is a sunny number. sunny number, right? And here in this example, 4 is not a sunny number. 4 is not a sunny number, right? So if the immediate number is a perfect square, then we call it as a sunny number. Well, now we'll go with the logic. So here first let us take the n value and then we'll find the immediate value. So and then we'll write the logic. So n is equal to int of input enter number. So we are taking some number. Now let me take an x is equal to n plus 1, that is the immediate number. So if n is equal to 3, 4 will be the immediate number. If n is equal to 10, 11 will be the immediate number. So we are incrementing that with 1 and this is the immediate number. And this one is the immediate number, right? Now we have to check whether this immediate number is a perfect square or not. So for that we'll go with a loop for I in range from 1 to x. So we'll check if I star I is equal to x. If any square matches with the x, we can say it is a sunny number. So we'll declare a flag as 1. We'll initialize a flag as 1 and then simply we can break. And if it is not possible, the flag will remain 0. So initially we'll give with the flag 0, and after completion of the for loop, if there is no perfect match, right? If there is no perfect match, automatically the flag will be remain 0 itself, right? So if there is any match, if it is a perfect square, then the flag will be set to 1 and we are just coming out from the loop, right? So finally, we compare the flag value. Based upon the flag value, we decide whether the number is a sunny number or not. So if flag is equal to 1, so we can say that print n is a sunny number. And if there is no perfect square, if the match doesn't equals, then simply the flag value will be remains 0. That implies print n is not a sunny number, right? So hope you understood this one. So if you consider a value n, the immediate number of that particular n must be the perfect square. So we are taking the I value from 1 to x. So in the range function, the x, if you are giving x as the upper bound, so x will not be included. So it will iterate from 1 to x minus 1. So in all those values, if there is any match, if there is any particular square, perfect square matches with this particular x, that implies it is a sunny number, right? So if I execute here, so if I give 3, so 3 is a sunny number because the immediate number is 4, which is a perfect number, okay, perfect square. And if I go with 8 is also a sunny number because the immediate number is 9, so the result is which is a perfect square. And simply if I go with a 10, it should not be a sunny number. So immediate number is 11, which is not a perfect square. One more example, if I go with a 24, it's a sunny number because the immediate number is 25, which is a perfect square, right? So 100, it's not a sunny number because 101, the immediate number is 101, which is not a perfect square. So hope you understood this one. So this is how we can find out whether the given number is a sunny number or not. So if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends. So just now we have seen the logic for finding the super digit. So first let us implement that. So let us read the input. So n is equal to int of input enter value. So n will be the input, and now we need to find the sum of digits until the sum becomes 1. So first I will write the outer loop. So while n, the value of n is greater than or equal to 10, so until it becomes true, it will be keep on iterating. So in that just I will copy this n to one more variable, and finally I will give the sum as 0, and now I will find the sum of the internal thing. So while x greater than 0 until x greater than 0, we need to repeat that. So first of all, we need to find the individual digits. So remainder is equal to r mod 10, so that we'll get one individual digit. So we have to add that particular digit. So I will go with the sum is equal to sum plus r, so that it will add the individual digits, and then we need to update the number. So x is equal to x mod 10, x floor division 10, and finally just pass the sum value to n. So in the next iteration, the n value become the sum of the current product, right? Some current digits. Now finally we can print the sum, so that we'll get the individual digit, right? So super digit for a given number is sum. So in the sum we are having the single digit, right? So we have seen the theoretical part, so that you have understood what exactly this one, right? I'm executing here. So 1 2 3 4 5 6. Oh sorry, r is not defined, so let us take r is equal, sorry, here it is r is equal to the number mod 10 will give the remainder. So yes, 1 2 3 4 5 6. You can observe here, you can add this one. 6 plus 5 11, 11 plus 4 15, 15 plus 3 18, 18 plus 2 20, 20 plus 1 21. So this loop will give the 21 as a sum, and you can see the sum value is not in single digit, so I will assign this into n. So now n becomes a 21, and again you have to iterate the same thing, so that the next one 21, 2 plus 1, it is a 3. So we got a 3 as a result. Once again, if you execute this one, so 1 3 5 7 9. So you can observe here 9 plus 7, it is 16, 16 plus 5 21, 21 plus 3 24, 24 plus 1 25. So in the first iteration it will be 25. Now the 25 will be assigned to n value, and we will iterate once again. So 25, so individual digit, sum of individual digits, that is a 2 plus 5, it gives 7. So super digit for a given number is 7. So a super digit is a value which is a sum of all the given, sum of digits of all given number until the sum becomes a single digit. Okay, so hope you understood this one. If you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll discuss about how to find the trimorphic number. So first, let us see what is this trimorphic number, and then we'll move on to the implementation. Trimorphic. So in the previous session, we have discussed about the automorphic number. So how to find the automorphic number. So similar to that, this is a trimorphic number. If n is a number and cube of n ends with n, then we call it as trimorphic number. So automorphic means if the square of a given number ends with the particular number, then we call it as a automorphic. And this is a cube. If the cube ends with the given number, okay, if the cube of an n ends with the n, okay, ends with a given number, n or a given number, right, then we can call it as a trimorphic. So let me explain the concept. That means let me take an example so that you will be understanding. So example 1, so let us take some n value as a 5. So n cube of n is equal to 5 into 5 into 5, which is equal to 125. So this number ends with 5, which is nothing but n. Okay, which is given number n. So 5 is a trimorphic number, right? So like this we have to do, and the logic behind this one is, in order to get the single digit, okay, single digit at zeroth place or zeroth position, we need to do mod some number mod 10. And if you want to get 2 digits, that means zeroth, sorry, zeroth and one's position, position, we need to divide or mod with a number 100. If you want to get 3 digits, so zeroth position and sorry, comma, ones and so don't get confused. Here we can simply write it as a ones position, okay, ones position, tens position. So instead of writing 0 1, we can simply write it as 0 ones and tens position. So here, so ones and tens and hundreds position. So simply we have to mod with 1000. Okay, so this is let us take this as a ones position, right? Ones position. Okay, there will be no confusion. Then what we have to do, I will give you an example now. I'll give you an example. See, example, let us take n is equal to some 5. So cube is equal to 125. So in order to get a single digit, in order to get single digit, what we have to do, 125 mod 10. Okay, 125 mod 10 will results 5. Similarly, 2 digit, that means 125 mod 100. Okay, 125 mod 100. If you do this one, what will get? It will results 25. Similarly, 3 digit, 125 mod 1000 will results 125, right? So and so on and so on. So for this purpose, in the first iteration, we'll use a 10 and we'll compare the result with a given number. If it is not equal, simply we'll repeat that by dividing 100 in the next iteration. If not equal, we'll divide the same thing by using 3 digit number. We'll repeat until the given number is greater than 0. I mean less than 0, less than or equal to 0. So until the given number less than or equal to 0, we have to repeat the thing, and every iteration we need to reduce the number of digits, right? So the same thing we have applied in the automorphic number, but the only difference is, in the automorphic number we have to check whether the number, the square of a given number ends with a given digits, right? And here it is a cube. Now let's start executing the program in Python. So first let us take the n value. So n is equal to so int of input. So I will increase the font. input, enter number, right? So after that, what we have to do, we have to find out the cube. Cube is equal to n exponential operator 3. So I'll take one more variable and I will initialize the n to that one, and I will initialize t is equal to 10. This is for updating in every iteration. So first iteration 10, second iteration will update with 100, next iteration will update with 1000. Okay, in order to get the number of digits. So we have to repeat the process until the number greater than 0, and use that, find out the remainder. R is equal to simply the cube mod t. For the first iteration it will be 10, and if R is compared with is equal to some n, the given number is n, so simply you can initialize flag as 1. So initially take the flag as 0, change the flag as 1, and break the loop. Okay, because if the comparisons are successful, we can simply say n is a trimorphic number, right? So if not, reduce the number with the number of digits, right? So in the first iteration, if it is a 3-digit number, in the second iteration we have to go with the 2-digit number, right? We need to reduce and update the t value. T value is t into 10. So in the first iteration, we are checking for first 1 digit, that is divided mod 10. In the second iteration, we need to check for 2 digits, that is mod 100, right? So in order to get 100, we'll increment this one with a 10 in every iteration. Initially it will be taken as 10. Now, after successful completion of this while loop, we'll check the flag value, and based upon the flag value, we can decide whether it is a trimorphic number or not. So, if flag is equal to 1, simply we can say n is trimorphic number, and if not, in the false condition, in the false case, we can declare is not a trimorphic number, right? So let us execute, take a 5. So we know that 5 cube is a 5 into 5 into 5, which is 125, right? So one more example, take a 49. 49 is also a trimorphic number. Let us check about this. So go to the calculator. So let us take 49 into 49 into 49. See, last digits are 49. So we can simply say 49 is a trimorphic number. 49 cube ends with the given number. Okay, and also we can say 6. 6 is also a trimorphic number. What about 3? So 3 is not a trimorphic number because the 3 cube is 27, which is not ends with a 3. And what about a 4? It's a trimorphic number because 4 cube is a 64, ends with a 4. So like this, we need to check whether the given number is a trimorphic or not. So the only one thing we need to remember, for every iteration we need to change the denominator of mod operator. So initially mod with 10 will get a single digit, and if mod is 100, if you are applying mod with 100, we'll get a 2-digit number, then 3-digit number, and so on. So in every iteration we are comparing that remainder with the given number. If any case, if it is equal, simply we are changing the flag value and we are coming out from the loop. So based upon the flag value only, we are deciding whether the given number is a trimorphic or not a trimorphic, right? So hope you understood this one, and if you are having any doubts regarding this trimorphic number, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll discuss about one more program in Python, that is to find the twisted prime, right? So first let us see what is the twisted prime, and then we'll go with the logic, and I will show the implementation using Python programming. So let us see what is a twisted prime. So if a number and reverse of that number are primes, then we call it as a twisted primes. So if number and reverse of given number both are primes, then we call it as twisted primes. Okay, twisted primes. So let us take an example so that you will be understanding perfectly. So example, so let us take some n is equal to 13 and we need to reverse of a number, right? Reverse of n is 31. So here you can see 13 is a prime where it is having factors of 1 and 13. Similarly, the reverse number of n is 31 and 31 is also a prime where it is having factors of 1 and 31, right? So we know that if any number is having the factors 1 and itself, we call it as a prime. So how to find the prime we have discussed in the previous session. So once again I am repeating. So we need to divide that particular number from number 2, because if we divide that number with 1, definitely we'll get a factor, right? So we have to start dividing that particular number, given number, from 2 to that number minus 1, because the prime will be having only factors of 1 and itself. So that means the number will be divisible by only 1 and that particular number. So apart from these two, we have to continuously dividing the given number with all the numbers in between, right? So if there is any factor appears, we can say it is not a prime, and if there is no factors, we can say it is a prime. So already we have seen this prime logic in the previous session. So please refer that one if you are having still any idea. Okay, need any idea. Now I will implement the same thing in Python. So first let us take the input. N is equal to int of input. The input function will read the input value from the keyboard, so number, and I will copy that number to another variable, right? Now let us first find the reverse of a number. So for finding the reverse of a number, simply iterate the loop until the number is greater than 0 and find out the remainder. That means finding the individual digit. R is equal to x mod 10, and we need to add some, right? So reverse is equal to reverse into 10 plus remainder. So it will automatically keeps on updating the number, right? And after that, after every iteration, we have to update the number. That means we have to reduce the number of digits. So if you take some 3-digit number, after first iteration, it should get the 2-digit number. So for that purpose, I am going x is equal to x mod 10. So simply after that, you can print and check the reverse number. See, now initially the reverse number, the reverse variable is equal to 0, because we are updating the value. So first initially we can take it as a 0. So if you consider 13, the reverse of a number is 31. Now we got the reverse of a number successfully. What we have to do next? So we have to check whether the given number and the reverse number are prime or not. Okay. So for that I am just writing the condition: if a prime of n and prime of reverse. Okay. So if both are true, simply we can say n is a twisted prime, right? And the false condition, if it is false, then simply we can write a else part here. So print n is not a twisted prime, right? Now here we are giving a prime of n and prime of reverse. So we need to find whether the n is prime as well as reverse is prime. So in order to write the two times the same logic 2 times, we can use a function. We can write a function and we can pass a different parameters. So that's what we are doing here. The prime of n, here the prime is a user defined function, and we have to write that user defined function. So first we'll write the user defined function. So prime, and here simply consider any other value, some m. Okay, so that if in this function call n will be copied to m, and in this function call reverse is copied to m. So what we have to do? We have to iterate from 2 to that particular -1, right? So for that, for I in a range of 2 to m. So in the range function, if you give m as a stop index, it doesn't include the m, so it will iterate till m -1. So m minus 1, what we have to do? We have to divide that particular number with each and every element, right? So if m mod I is equal to 0, if there is any division successful, that implies it's a factor. So we can simply go with a flag is equal to 1 and you can break. So even though if any one factor is there, we can simply say it is not a prime, right? And after that, simply give here, after the for loop, check the condition, check the flag value. If flag is equal to 1, that means it's not a prime, so return 0. So if you return 0, that is a false condition, right? So else return 1. So if it returns 1, so this value will become 1 and this value becomes 1, right? So initially we'll consider the flag value as 0, right? So after executing this one, so first we are writing the function definition. So this will be executed only after the function call. So this will be executed. So we'll get the reverse of a number, and then we are passing n value to the prime function and reverse value to the prime function. So if both the values are true, then only we can say n is a twisted prime. Otherwise, we'll get the not a twisted prime. Okay, so you can execute this one. So I will give 31. So 31 is a twisted prime. So I will remove this one. Or here simply you can print both the values. Print. So number, a given number n, and again print reverse of a number RUB, right? So if you go with 31, see, given number is 31 and reverse of a number is 13. So 31 is a fixed prime because both are primes. Okay, so you can take one more example, 17 or 71. So 71 is a prime. So if you execute, the given number is 17 and reverse of a number is 17, so it will be a twisted prime. And one more thing, 23 is a prime, but the reverse of a number is 32, which will be having a factor, right? It's not a prime. 32 is not a prime. Even though 23 is a prime, reverse of a number is not a prime. So simply we can say 23 is not a twisted prime, right? So a number is called as a twisted prime if that particular number and the reverse of that particular number are both primes. Then only we can say it as a twisted prime number. Right? So hope you understood this one, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So in today's session, we'll go with one more program in Python, that is finding of unique number. So first let us see what is the unique number, and then we'll write the logic in Python. So unique number. So any number having unique digits, right? Or no duplicate digits is known as unique number, right? So example, let us take an example. So consider n is equal to 1, 2, 3, 4, 5. So here all are unique, right? The count of each and every digit is only 1. So there is no repetition of any digit. So no repetition of any digit. So 1, 2, 3, 4, 5 is unique number. Consider n is equal to 1, 2, 3, 1, 2, 3. So here, so 1 is having 2 times. 1 is repeated 2 times, 2 is repeated 2 times, and 3 is repeated 2 times. So that means there are duplicates, right? So there is repetition of digits 1, 2 and 3. So 1, 2, 3, 1, 2, 3 is not an unique number, right? Hope you understood. It should the digits should not be repeated, right? So now we'll write the logic, and here the logic can be written in two ways. One is by using the set function. So first we'll find the length of string of n, right? So we'll convert the given number into a string so that we'll get the length. Then we will apply the set function of this particular string of n, and again we need to find the length, right? And these two must be equal, right? So after applying the string format of number into a set function, so that it will remove all the duplicates and the length should be equal for both these things, so then we can simply say the number is a unique number. But here I will let you know, I mean I will explain the logic without using the set function. So I'm not going to use the set function. So first of all, let us take the number n is equal to int of input and enter number, and now we'll find the individual digits and we'll append the individual digits into a list, right? So first we'll find out the digits. So in order to find the individual digits, we have to use a iteration and find the remainder is equal to n mod 10, so that we'll get an individual digit and simply add that one. So I will take a list, L is equal to list function, it's a list. We will append each and every remainder. So here the remainder is individual digit. Here the remainder is individual digit, right? So I will append this one. So L dot append function of remainder, and we need to reduce the number of digits. So first let us take 3-digit number. After this one we need to find the 2-digit number, then 1-digit number. So in order to reduce the digits, n is equal to n floor division of 10, so that this will reduce the number of digits, right? Now if you print L, so we'll get individual numbers. I will take 1, 2, 3, 4, 5. So you can observe. So 1, 2, 3, 4 and a 5. So we have appended each and everything. Now we'll just find the count. Okay, we'll iterate each and every element. So element in L, if we will find the count. So if L dot count of element is greater than 1, so being a unique number, the digit count should be only 1. So if there is a 2 occurrences, automatically the count of that particular element will be greater than 1. If the count is greater than 1, simply you can print let us take one more this one. So x is equal to n. Now we can display the x value, because we are updating the n, so that n will be changed. So I am just assigning the n value to one more variable x. Now here I am writing x is not unique number, right? Otherwise, after completion of all the iterations, right, else, simply you can write a else. So we can write a for with the else, right? So after successful completion of all the elements, so if this is not executed, then simply we can say x is unique number. So if you execute here, so 1, 2, 3, 4, 1234, here you can see all the digits are single, right? So only once it was repeated. So you can get 1, 2, 3, 4 is a unique number. If you find 1, 2, 3, 1, so 1231, here you can find 1 is repeated 2 times. So here the count will be greater than 1. So simply we'll get this answer. See, not a unique number. Okay, so we are getting a multiple times. Okay, we are getting the multiple times. So you can simply break here. So once it was break, automatically see 1231. So it's not a unique number. So in the absence of break, for every element it will check and it will print. Okay, so that's why we just give the break. So whenever the break statement is executed, automatically this else will not be executed, because so the condition is not completed, but irrespective of the condition, we are just breaking the condition. Okay, breaking the loop. So that's why else part will not be get executed, right? So 121, 1 is repeated, so we'll get 121 is a not a unique number. And if it is not repeated 1 2 3, it's a unique number. So otherwise, so if you are having a still confusion, you can simply use a flag. Okay, flag is equal to 0, and here instead of printing this one, give the flag is equal to 1, and based upon the flag you can print here. So if flag is equal to 1, so here you can print x is not unique number, right? And simply else part. So based upon the flag we can display the result. This is another way. So 123 is a unique number, and 121 is not a unique number, right? So a number which doesn't have the repeated digits is known as a unique number. So hope you understood this simple logic. So this can also be implemented by using the set function, right? So I will give that example. So input enter number. So simply we can go with the length of so L1 is equal to a length of str of n. Okay, L2 is equal to, so simply length of set of str of n. So simply we can write it, if L1 is equal to L2, so print n is a unique number, otherwise else. So in the false condition we can simply write it as n is not a unique number, right? So 123 is a unique number and 121 is not a unique number, right? So first we are applying the string function. So we are converting that number into a string function so that we can find the length. In the second one, L2, so we are applying the we are changing the number into a string, and we are applying it to the set, so that if there are any duplicates it will be removed, right? So automatically if we are checking the length, if there are no duplicates, the length should be equal here. Even though you are applying to the set function, the length should be equal. So we can simply compare these two lengths, so automatically we'll get the result, right? Based upon this result, I mean this comparison, we'll find whether it is a unique number or not a unique number. So these are the two ways, but so prefer this one without using the functions, set functions and all these things. So use this one, because most of the competitive coding examinations doesn't accept using the functions, right? And here we can use the count function. So without using the count also we can do that. So you can also try with that and you can find the uniqueness, right? So hope you understood this one, and if you are having any doubts regarding this unique number program, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.